Hey, today I want to talk about the review for derivatives, integrals, and the improper integrals. So we can go over these things together. The first one, we think about differentiation formulas. You have to memorize this whole differentiation formulas. The first one, the constant prime is like 0. The x prime is 1. The x to the n prime is n times x to the n minus 1. The c times f prime, you can take out c times just f prime. F plus minus g prime is, you can distribute prime, f prime plus minus g prime. F times g prime is the first one prime times the second one plus first one times second one prime. The f of g prime is like quotient rule. The top one prime times the bottom one minus top one times the bottom one prime over bottom one squared. The sine prime is cosine. The cosine prime is negative sine. Tangent prime is secant square. Cotangent prime is negative cosecant square. The secant x prime is the positive secant x tan x. The cosecant x prime is negative cosecant times cotangent. Do you remember chain rule? What's it like a chain rule? F of g of x prime is f prime of g of x times g prime of x. The power rule combined with the chain rule. G of x to the power n prime is n times g of x to the n minus 1 times g prime of x. The differentiation formulas. What is it like ln of x prime? The 1 of x. ln of g of x prime, you can do chain rule. G prime of x over g of x. Do you remember, was it like log x with the base a prime? Could you run your answer? What is log x with the base a prime? What do you think? So in this case, so you can use like this one. You can change log x with the base a is ln of x over ln of a. You just only take out ln of a just like this. The ln of x prime. So we have 1 over ln of a times ln of x prime is 1 over x. Answer is 1 over x times ln of a. So that's it. This is the whole idea. So what's e to the x prime? The e to the x prime is e to the x. The e to the g of x prime is, you can use chain rule, e to the g of x times g prime of x. A to the x prime is the a to the x times ln of a. The a to the g of x prime is a to the g of x times ln of a times g prime of x. The inverse sine of x prime, the 1 over square root of 1 minus x squared. Inverse cosine of x prime is minus 1 over square root of 1 minus x squared. The inverse tan x prime. Do you remember what is the inverse tan x prime? Could you write your answer on the chatting board? What is the answer? Inverse tan x prime. Do you remember? Yeah, you're right. 1 over 1 plus x squared, 1 over 1 plus x squared. Yeah. Inverse cotangent x prime is negative 1 over 1 plus x squared. Inverse secant x prime is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is minus 1 over x times the square root of x squared minus 1. So next one. How can you find the derivative of inverse function? We can use one theorem. The function f is one-to-one differentiable function with inverse function f to the minus 1n. The f prime of inverse of f at a is not equal to 0. So we can use this result. The inverse function is differentiable at a. This is result. Inverse function f prime of a is 1 over f prime of inverse of f at a. Yeah, this is exactly formula. The next, we think about some examples. The f of x is the 3x plus cosine 2x. Find inverse f prime of 1. The first, I want to check. Function f is 1-to-1 or not. Function f is 1-to-1. Yes, we have this result. So you can check. How can you check? Take derivative. F prime of x is 3x plus cosine 2x prime. The 3x prime is 3. Cosine 2x prime is, you can use chain rule. Cosine prime is negative sine of 2x times the inner function 2x prime is 2. So we have this one. So what's that? So this is here. This sine function is always between negative 1 and positive 1. You can plug negative number into here. Minus 2 times minus 1 plus 3 is 5. So what's like a maximum value? You can plug a maximum value into sine 2x. The negative 2 times 1 is negative 2. The 3 minus 2 is positive 1. What does it mean? This is always positive number. So function f is increasing. So what happens? Function is like increasing function. I want to use horizontal line test. You can draw any horizontal line. So we have only one intersection point. So what does it mean? Function f is 1-to-1. Okay, the next tip. You can use theorem. So we can follow these steps. The step 1. You can find inside 1 inverse f of 1. Here, inverse f of 1. We don't know, I can write x. You can use definition. What's the definition? So here, f of x equals 1. This is relation between inverse function and the function f. What's like f of x? This f of x is here, 3x plus cosine 2x. So we have 3x plus cosine 2x equals 1, right? You need to find x value. So what is x? What is x? So satisfying this equation, 3x plus cosine 2x equals 1. What's that? 0? Yeah. So you can plug x equal to 0 into the here. So what happens? The 3 times 0 plus cosine of 2 times 0 equals 1. The 3 times 0 is 0. Cosine of 0 is 1. Yes, 1 equals 1. So we have answer. X is 1. So this x value is 1. What does it mean? This one is like 0. So we need to calculate 1 over f prime of 0. You can change it like this. Step 2. You need to calculate f prime of 0. F prime of 0. We already have f prime of x here. You can plug 0 into here. So we have 3 minus 2 times sine of 2 times 0. What is sine of 0? What is sine of 0? Yeah, this is going to 0. So we have 3. So you can plug 3 into here. What is the answer? Answer is 1/3. That's it. This is whole idea for solving this problem. So like this. The next problem. You can define derivative of f of x and g of x. So we can use differentiation formulas. The first one. So what's like the best way? This is like powers here, powers down. We can use this rule. ln of a to the power n. What happens? N is like down. The n times ln of a. So like this. So this is same to 2 times ln of cosine 3x prime. So what's that? We can use this rule. ln of g of x prime. What's it like ln of g of x prime? ln of g of x prime is g prime of x over g of x. We can use this rule. So we have 2 times, so cosine 3x prime over cosine 3x. So next, 2 times, you can just chain rule. Cosine prime is negative sine 3x times inner function 3x prime. 3x prime is 3 over cosine 3x. So what's that? You can keep 2 times minus 1 times 3 is negative 6 times. What is sine over cosine? Remember one identity, sine over cosine. What is the sine over cosine? Yes, we have a tangent function. It's good. So we have tangent 3x. So that's it. This is answer of f prime of x. So next one. Was it like g prime of x here? G prime of x is 1 over arc sine of e to the 3x prime. So what's it like idea? So we have 2 things possible. So we can use quotient rule or power rule. Either one is fine. So I want to use it like a quotient rule for solving this problem. Like 1 prime times arc sine e to the 3x minus 1 times arc sine e to the 3x prime over arc sine e to the 3x squared. So like this. So and calculate. The 1 prime is 0. This whole thing is 0. Was it like arc sine e to 3x prime? Do you remember? Was it arc sine x prime? The arc sine x prime is 1 over square root of 1 minus x squared. So you can plug e to the 3x into here. So we have keep negative 1 over the square root of 1 minus arc sine. E to the 3x. The e to the 3x. E to the 3x prime square times inner function e to the 3x prime over arc sine of e to the 3x squared. So what's that? E to the 3x prime. We can combine this one numerator. Negative e to the 3x prime is e to the 3x times inner function 3x prime. Inner function 3x prime is only 3 over the square root of 1 minus the e to the 3x squared is only multiply 3x into 2. The 3x times 2 is 6x, e to the 6x times the reciprocal of denominator 1 over the arc sine of e to the 3x whole squared. So like this. Okay, this is like answer of this question. So like this. The next one. What is logarithmic differentiation? The logarithmic differentiation is used for finding derivatives of complicated functions involving products, quotients, or powers, or f of x is g of x to the h of x. The base is a function, power is a function. We can use logarithmic differentiation. So examples, f of x equals x plus 2 to the 4 times sine square of x over cube root of x. F of x equals square root of 2x minus 1 over 2x plus 1. Exactly complicated function here involving product, quotient, and power, right? Same. Quotient, you can change this one to the 2x minus 1 over 2x plus 1 to the power 1 half, like a power form. Or y equals ln of x to the power 1 of x, exactly g of x to the h of x form. How to find? We can follow 3 steps. Step 1, take natural logarithms of both sides of an equation y equals f of x and use the laws of logarithms to simplify. Step 2, differentiate implicitly with respect to x. Step 3, solve the resulting equation for y prime or f prime of x. I will apply this method to the last one, y equals ln of x to the power 1x. What's step 1? Take ln here. So what happens? This is 1 over x is like down. The 1 over x times ln of x. So the ln of x is a numerator, ln of x over x. Step 2, take derivative the both sides, right? Take derivative the both sides, like this. So how can you solve this derivative? Here. This part is, you can use chain rule, y prime of y, what is portion? So we can use quotient rule, top one. ln of x prime times x, ln of x times x prime over x squared. What is this one? You can use chain rule, inner function prime over inner function. This is 1 over x over ln of x. Same to 1 over x times ln of x. X prime is 1 over x. So we have it like this. Oh, sorry. X prime is not 1 over x. So 1. Sorry about that. This is 1. So next is the simplify. The x is like it, crossed out. So we have it. This one. Next, I will multiply top and bottom by denominator ln of x. So what happens? Distribute this one. So what's that? ln of x is gone. 1 minus here. ln of x times ln of x of ln of x times x squared. So we have it done like this. The next step, step 3. What is like step 3? So you can solve this equation for y prime. What does it mean? You can multiply the both sides by y. So like this, the y. So what happens? Y is crossed out. This y is exactly same to this one. You have to plug this one into here. So we have this result. ln of x to the 1 over x times 1 minus ln of x times ln of x over x squared times ln of x. This is like idea. The next thing, so you need to memorize most important integrals. So integral kx dx is, what's that? What's integral kx dx? Yeah, kx plus c. Integral x to the n dx is 1 over n plus 1 x to the n plus 1 plus c. In this case, n is not equal to minus 1. n equals to minus 1, integral 1 over x dx, we have ln of absolute value of x. Really be careful, this one. Absolute value of x plus c. integral g prime of x g of x dx is ln of absolute value of g of x plus c. integral e to the x dx is e to the x plus c. integral e to the kx dx is 1 over k e to the kx plus c. integral a to the x dx is, really be careful, this is a to the x over ln of a plus c. integral sine x dx is negative cosine x. Do you know this one? What is integral sine kx dx? Do you know that? What is the answer? What's integral sine kx dx? So you can use u substitution. The kx equals u, you have to use u substitution, exactly 1 minus 1 over k cosine kx plus c, like this. What's cosine x? Integral cosine x is sine x plus c. So similar. What is integral cosine kx dx? What's that? Could you run your answer on the chatting board? What is the answer? Integral cosine kx, do you know? The answer is the similar. You can use, 1 over k times sine kx, you're right. 1 over k sine kx plus c, you're right. Like this. The integral secant squared is 10. integral cosecant squared is negative cotangent x plus c. integral secant times tan x dx is secant x plus c. integral cosecant cotangent dx is negative cosecant x plus c. integral tan x is the ln of absolute value of secant x plus c. integral cotangent x dx. So this one, though, you don't need. You don't need it. integral secant x dx, you need to memorize. ln of absolute value of secant x plus tan x plus c. integral cosecant x is this one, but same. You don't need it. integral 1 over square root of a squared minus x squared is inverse sine of x of a plus c. integral 1 over a squared plus x squared dx is 1 over a inverse tan of x over a. This is like this one. So do you remember u substitution? Do you know u substitution? So you need to know also u substitution. What's it like u substitution? Here I can write. You need to know substitution rules. So we have integral f of g of x times g prime of x dx. So how can you change? The u equals inner function g of x, the du equals g prime of x. You can plug into here. This is like u, f of u. The g prime of x dx is here, du. So like this. So you can find antiderivative by using most important integrals and then find the answer. So what's like a definite integral version? The integral, the f of g of x times g prime of x. So from A to B. This one, you can use same U substitution inside is exactly same to the previous one. Integral f of u du. So how can you change a and b? You can use this relation u equals g of x. You plug a into x, the lower limit is g of a. You plug b into x, upper limit is g over b. So like so, right? This is called the substitution rule. The next is strategy for integration. So type 1, integral f of x times g of x dx form. So where f of x times g of x is the product of polynomial and transcendental function. So do you know what's like a transcendental function? So we have these kind of things. So we have exponential function or logarithmic function or inverse trig function, or trigonometric functions. So we have 4 kind of things we call transcendental function. Or 2 transcendental functions use integration by parts. What's that? Integral u dv equals u times v minus integral v times du. So this equation, how do you choose u from the integrand of an integral? Use a principle of precedence for u. You remember LIATE. We can use this order. The L is logarithmic function, I is inverse trigonometric function, the A is algebraic function, T is trigonometric function, E is exponential function. The remark, we can interchange L and I, we have the same answer, it doesn't matter in this case. So type 2, integral sine to the power mx cosine power nx dx. How can you solve case 1? So power m from the sine function is odd power. Step 1, save one sine function from the odd power. The step 2, you can use substitution. You can save sine, u is the other one cosine. The du equals cosine prime dx. Cosine prime is negative sine x dx. You multiply the both sides by -1. Negative du equals sine x dx. Step 3, you can change so cosine function, sine function to the cosine function by using identity. Sine square of x equals 1 minus cosine square of x. You can plug u into here, 1 minus u squared. Second case, n equals 2k plus 1. The power of a cosine function is odd power. Step 1, save cosine. You can use u substitution is exactly step 2. U is the other one sine. The du equals sine prime dx. Sine prime is cosine x dx. Step 3, use identity. Cosine square of x is 1 minus sine square. You plug u into sine 1 minus u square. The third case, like power m is even, power n is even. All powers are even. So you can use the half angle formulas. What's half angle formulas? Sine square of x is 1 over 2, 1 minus cosine 2x. Cosine square of x is 1 over 2, 1 plus cosine 2x. Step 2, you have to use this formula. Integral cosine kx dx is 1 over k sine kx plus c. This is like a second type. The another second type is integral tangent to the power m secant to the power nx dx. What's case 1? M equals 2k plus 1. This is like odd power. So save one secant and tangent factor. Step 2, u substitution. U equals secant. du equals secant x tan x. This is the reason why you save secant and tan x. du is secant and tan x dx. This is the reason. Step 3, you have to use identity. Tangent square of x is secant square of x minus 1. This is u square minus 1, right? Because, so u equals secant, plug into here. Second case, like power n is 2k. So in this case, you can save secant square of x. Step 2, u substitution, u equals tangent. du equals secant square of x dx. So step 3, use identity. The secant square of x is 1 plus tangent square of x. So this is 1 plus u square because u is tangent. You plug into here. The case 3, other cases, we don't have a guideline. The guidelines are not as clear cut. We don't have it. So this is only case by case. The step 3, the type 3. The integral f of x where f of x contains following expression. So this kind of expression here. So do you know this one? So what kind of expressions? Expression is like this one. A square minus x square form. Another one. A square plus x square form. Third one. A square, not a square. X square minus a square form. We have this expression. So how can you solve this problem? You have to use substitution rules. The first case, what is x? What is x? Do you know what is x? So we call this one the trigonometric substitution, right? So this is like a trigonometric substitution. What is x? Remember? So we have a times sine theta, sine x. Oh, sorry, sine theta. A equals sine theta. So here, what is x? Second one. So a times tangent theta. You're right. What's the third one? Third one is, do you know this one? A times secant theta. So you can find du. First one, du is a times sine prime a cosine theta d theta. So what's it like? Sorry, tx. Sorry, tx. Here, tx is so a times tangent prime is secant square of theta d theta. Here, dx is a times secant theta prime is secant theta tan theta d theta. Like this. The next, you have to change this one to the simple form by using identity. So this one, what kind of identity do you need? Do we use the like this? So cosine square of theta is 1 minus sine square. So we have 1 minus sine square of theta is cosine square of theta. You can use it. So this case, so we use 1 plus tangent square. 1 plus tangent square root of theta is change secant square root of theta. Third one, what's that? The secant square root of theta minus 1 is tangent square root of theta. You can use this identity. The next, you have to change back the theta value to the x value. How can change it? We can use triangle. So we can use this substitution. X equals a times sine theta. You divide by a. So we have x of a equals sine theta. You can draw triangle. Sine theta is here, opposite over hypotenuse. How can you find the adjacent? By using Pythagorean theorem. So we have a square minus square root of a square minus x squared. Here we can use x equals a tangent theta, the same, divided by a, x of a equals tangent theta. You can draw triangle. Tangent theta is opposite over adjacent. How can you find hypotenuse? You can use Pythagorean theorem. This is a squared plus x squared. The last one, we can use x equals a secant theta. So we have divided by a, x over a is secant theta. You can draw triangle. This is angle theta. What's like a secant theta here? Secant theta is hypotenuse over adjacent. You can use Pythagorean theorem. So we have x squared minus a squared. This is the whole idea for solving this kind of problem. So we call the trigonometric substitution. So we can use it like this. Type 4. So we have integral of polynomial over polynomial form. How can solve? Case 1. Top on power is less than bottom power. Top on power is less than bottom power. We use only partial fraction. Second case, top on power is greater than bottom power. Here, top on power is greater than or equal to bottom power. You can use long division and partial fractions. Step 2, you can use useful integrals. What's integral 1 of x? ln of absolute value of x plus c. Integral g prime of x over g of x dx is ln of absolute value of g of x plus c. Integral 1 over a squared plus x squared dx is 1 over a inverse tan of x of a plus c. Integral x to the n dx is 1 over n plus 1 x to the n plus 1 plus c. So sometimes you need to use double angle formula. Sine 2x is 2 times sine x cosine x. Cosine 2x is cosine square of x minus sine square of x, or two more things. 2 cosine square of x minus 1, 1 minus 2 sine square of x. We have these identities. Type 5. Integral f of x dx where f of x contains the nth root of ax plus b or nth root of g of x. What's it like? How can you solve this problem? First, try to use substitution rule by u equals inner function ax plus b or u equal to g of x. If it is impossible to use this one, you can change u substitution. U is whole thing. Nth root of ax plus b or u equals nth root of g of x. Summary. So how to evaluate the integral? Integration formulas, substitution rule, integration by parts, trigonometric substitution, or partial fractions. We have 5 methods for solving integral problems in Math 141. I'm going to give examples here. integral from 0 to square root of 3 x over 9 plus x to the 4 dx. How can you solve? We have 5 method. Integration formula, substitution, integration by parts, tricks of partial fraction. So which one? Tricks of is, this is better. We have only, tricks of is possible, but the more complicated. In this case, here, only problem is 9, bottom one has 9 plus x squared, it's good. X is 3 times 10 theta, it's good idea. But this is x to the 4. Was it like the best way? You can change this one to the root 3 and 0 x over 9 plus, you can change it, x squared dx form. You have to use u substitution better. The u equals inner function x squared. The du is the 2x dx, only divided by 2. So what's that? So this is same to 1 over 2 du equals x dx. This is like idea for solving this problem. Like this. So you have to substitute. How can you substitute? Here, integral, the x squared is exactly u. The bottom one is 9 plus u squared. What's like x dx? X dx is 1 over 2 du. 1 over 2 du. The next, you can change lower limit, upper limit. You plug 0 into here, exactly g of 0. You plug root 3 into here, g of root 3. Like this, so we have it. The next, simplify. Only take out 1 over 2. What's like a g of 0? You plug 0 into here. 0 squared is 0. You plug root 3 into same x. The root 3 squared is 3. So this whole thing is just 3. You can change 0 and 3. So like this. So do you remember what's the formula? This one? What's the formula? What's integral 1 over 3 squared plus u squared du? Do you know this one? Integral 1 over the a squared plus x squared dx. We can use integration formula. So 1 over a inverse tangent of x over a plus c. This one. So we have next one. You can keep 1 over 2. So this integral is exactly same to 1/3 inverse tangent of u over 3. So we have here, plug 3 into this one, we have it. You plug 0 into here, so we have it. So what is inverse tangent of 1? What's inverse tangent of 1? What's that? Yes. This is unknown value theta. You can use relation between inverse and the original function tangent. 1 equals tan theta. What's angle theta? Angle theta is pi over 4. So you can do key. Here, key 1 over 6. Inverse tangent of 1 is pi over 4. What's inverse tangent of 0? We can use same method. Inverse tangent of 0 is angle theta. You can use the definition. The 0 equals tangent theta. The theta equals angle 0. This whole thing is going to 0. Answer is pi over 24. This is answer of this question. Right? Like this. The next one. Here, how can you solve? equal 1 over x times ln of x dx. How can you solve? So which method do you want to use? Use substitution, integration by parts, the trigonometric substitution, or partial fractions. So which method do you want to use for solving the first integral problem? Partial fraction. Partial fraction, when you use a partial fraction is polynomial over polynomial things. In this case, one is a polynomial, but ln of x is not polynomial, so we cannot use partial fractions. So do you have any idea for solving integral 1 over x times ln of x? The same. You have to use u substitution. What is u? u equals ln of x. What is du? du is 1 over x dx. Luckily here, 1 over x dx is, yes, du. You can change it very simply. You have to use u substitution. Like this. So what's that? You can change it. Here, 1 over. The ln of x is u. What is 1 over x dx? 1 over x dx is just du. We have simple one. Next, you plug the e into here, g of e. You plug e cube into here, g of e cube. Like this. This one. So what's that? This is 1. You can watch it g of e. The g of e is exactly same to plug e into here. The ln of e. ln of e is 1. Here, you can plug e cube into x. We have ln of e cube. ln of e cube is 3 times ln of e. The 3 times 1 is 3. So you can change it. 1, 3. The next, what is integral 1 over u? Integral 1 over u is ln of absolute value of u from 1 to 3. So this is same to ln of absolute value of 3 minus ln of absolute value of 1. What is ln of 1? What's ln of 1? Yep, 0. The final answer is ln of 3. So that's it. So like this. The next one, this is similar. This is x cube is like u. So what's x cube prime? X cube prime is 3x squared dx. U substitution is like better. U substitution, u equals x cube. du is the 3x squared dx divided by 3. The 1/3 du equals x squared dx. So you have to substitute. So this is same to integral. So this x cube is here. The u, e to the u. So x squared dx is 1/3 du. We have 1/3 du. You can take out 1/3 integral 1 over e to the u is e to the negative u du. You keep 1/3. What is e to the negative u du? What's integral e to the negative u du? What's integral e to the negative u? Do you know what's integral e to the negative u? Yep, e to the negative u times minus 1. Because, do you know this one? E to the kx dx. What is the answer? 1 over k e to the kx plus c. So, in this case is e to the negative u du. What's that? 1 over k is minus 1. E to the minus u plus c. We have negative e to the minus u plus c. So we have here negative e to the u plus c. The next change back. So minus 1 times 1/3 is negative 1/3. E to the minus, sorry, is negative u here. E to the negative was like u. U is ln of x. No, x cube, sorry. X cube plus c. So we have the negative 1 over, I can change it, positive exponent, the 3 times e to the x cube plus c. This is like idea for solving this problem. So like this. The next thing, how can you calculate integral 1 to e ln of x over x cubed dx? So same. How can you solve? Which method do you want to use? The u substitution is possible? U substitution? The u substitution is possible? No. Because you can choose u. What's like the best choice? U equals ln of x. The du is 1 over x dx but x cubed. Not easy. So don't use u substitution. Partial fraction, no. Because not polynomial over polynomial form, we cannot use the partial fraction. Tricks of is impossible. We don't have the constant minus x square, constant plus x square minus constant, just x cubed, not x squared. So we cannot use the trigonometric substitution. What is like the remaining method? The remaining method is integration by parts. So when you use integration by parts, you can read my review part. So product of two functions, algebraic function times transcendental function. This is exactly algebraic function times transcendental function. Why here? This is one over x cubed is algebraic function times the logarithm function is transcendental function. That's it. This is the reason. We can use integration by parts. Integration by parts. We can use this idea. So you can decide, so which one is like u. So you have to use this one. This is integration by parts. So LIATE. So what's that? I just said it before, this is same to what? This one. So we have 1 over x cubed times ln of x dx form. So what's it like 1 over x cubed? 1 over x cubed is algebraic function. 1 over x cubed is algebraic function. ln of x is logarithm function. So which is like higher? ln of x is higher than 1 over x cubed. So u equals, what's u? Exactly. U equals ln of x. What's like dv? dv is 1 over x cubed dx. Do we have it? The next, find du. du is ln of x prime. We have 1 over x dx. Find v. Do you know what's v? The dv equals 1 over x cubed dx. What's v? What's v? What's v? Yes, minus 1 over x squared. How can you find the v? Integral. Integral 1 over x cubed dx. You can calculate here. You can calculate the integral, the 1 over x cubed dx. You calculate. This is same to integral x to the negative 3 dx. You can use this rule, the negative 3 plus 1, x to the negative 3 plus 1 plus c. So this is what? The 1 over minus 2. So we have negative 1 over. So we have 2. X to negative 2 is x squared plus c. So what's it like v? The minus 1 over. This is a very important thing. Coefficient. 2x squared is like v. The minus 1 over 2x squared. So you can use this rule. U times v. U times v is this one. U times v. So we have negative 1 over 2x squared ln of x from 1 to e minus integral 1 to e the v times du. The v times du is this one. V times du. So we have minus 1 over 2x squared times 1 over x dx. This one. So simplify. You just only plug e into here. What's that? Negative 1 over 2 times e squared ln of e minus plug 1 minus 1 over 2 times 1 squared ln of 1. So one more. You can take out minus 1 half here. The minus 1 times minus 1 half is positive 1 half integral. The 1 over x squared times 1 over x is 1 over x cubed. 1 over x cubed dx from 1 to e. So calculate. What's that? The ln of 1 is 0. What is ln of e? Do you know ln of e? Yep, this is 1. So 1 times minus 1 over e, 2 times e squared is negative 1 over 2 times e squared. So here, plus 1 over 2 times integral 1 over x cubed is here. We have this calculation. Minus 1 over 2 times x squared. So minus 1 over 2 times x squared from 1 to e and simplify. Minus 1 over 2 times e squared. This is negative 1 over 4 times x squared from 1 to e. You plug negative 1 over 2 times e squared minus you plug top one into x 1 over 4 times e squared minus 1 over 4 times 1 squared. So this is minus 1 over 2 times e squared. Distribute negative 1, the minus 1 over the 4 times e squared. The negative is positive plus 1 over 4. You can combine these two things. So we have negative 3 over 4 times e squared plus 1 over 4. That's it. This is final answer for solving this problem. Like this. Next thing. How can you solve this problem? Integral x squared times sine 3x dx. How can you solve? The same. Use substitution, integration by parts. So partial fractions, the trigonometric substitution. So which method is possible for solving this problem? Yes, integration by parts, the same reason. So what's that? This is x squared is algebraic function times the trigonometric function. The trigonometric function is transcendental function. Algebraic function times transcendental function, so we can use integration by parts. So here, same. We chose it like a u, so this is the same idea. So here, x squared is algebraic function here. Sine 3x is trigonometric function here. Sine 3x. So what's that? You can use this one. Was it like u? U equals top on x squared. Was it like dv? dv is remaining part sine 3x dx. So find du. The du is, oops. The du is 2x dx. Was it like a v? The v is integral 3x. Was it integral 3x? Integral sine 3x. Integral sine 3x dx is exactly same to the negative 1/3 cosine 3x. So like so on. So you can use here u times v. So we have the negative 1/3 x squared cosine 3x minus integral the v times du. v times du is negative 1/3 cosine 3x times 2x dx. You can change it a little bit. This is negative x squared, negative x squared cosine 3x over 3. This is a take out minus 1/3 and the 2. The negative 1 times minus 1/3 is positive 1/3. Positive 1/3 times 2 is positive 2/3. We have 2/3 integral the x times cosine 3x. X times cosine 3x dx. The next one. How can you calculate integral x cosine 3x dx? We can use integration by parts again because x is algebraic function, cosine 3x is trigonometric function, transcendental function. You can use same things. Was it like x? X is algebraic function, cosine 3x is trig functions. Which one is like u? Higher one. X is u. You have to use one more. U equals x. The dv equals cosine 3x dx. Was it like a du? The du equals x prime is 1 times du, dx. Was it like a v? The v is integral cosine 3x. Integral cosine 3x is 1/3 sine 3x, this one. So you can use this rule. You can keep minus x squared cosine 3x over 3 plus keep 2/3. You can do bracket here, same. U times v. So we have the 1/3 times x times sine 3x minus integral the v times du. V times du is 1/3 sine 3x dx. So like this. So next, you can distribute 2/3. This is negative x squared cosine 3x over 3. So 2/3 times 1/3 is 2 over 9. So 2 times top one is the 2x sine 3x over 9. The 2/3 times 1/3 is exactly negative 2 over 9 이내거 sin 3x dx, sin the 3x dx. So we have it. The next, calculate last part. So what's it like this one? The last one is exactly same to the 1/3, negative 1/3 cosine 3x is right. So final answer is the like this one. So we have negative x squared cosine 3x over 3 plus 2x sine 3x over 9. The negative 2 over 9 times minus 1/3 is positive 2 over 27. The top one is 2 times cosine 3x over 27 plus c. So that's it. This is final answer for solving this problem. How can you solve? You can use integration by parts twice. The next tip. integral sine to the power 5x cosine square of x dx. How can you solve? Do you remember this kind of problem? How can you solve? The use substitution, integration by parts, partial fraction, the trigonometric substitution, which one? Don't use trig sub. So because when do you trig sub? The trig sub is exactly the constant minus x square form, constant plus x square form, the x square minus constant form. So we can use trigonometric substitution. In this case, you can use, remember? So this is integral of, yes, integral of the sine to the 5x cosine square of x. Usually use substitution here. Which one is like odd power? So 5 is like odd power, was like step 1. You can save 1 sine x, save 1 sine x from odd power, the next one. You can change sine to the 4x cosine square of x. You can save sine, in this case, was like u. U is the other one, cosine. So cosine x was like du. du is cosine prime. The negative sine x dx. So we can multiply -1 by -1. Negative du equals sine x dx. So let me see. So u equals cosine. This is like u square. How can you change sine to the 4 to the u value? You have to use identity. What's like identity? We can use sine. The square of x is 1 minus cosine square of x. What's like cosine x? Cosine x like u, plug into here, 1 minus u square. So how can change? Integral. Sine to the 4 is change the scale form. So like this one, cosine square of x sine x dx. So this is same to integral. Sine square of x is here, 1 minus u squared. But cosine x is u, only u squared. Sine x dx is negative du. We have negative du. You can take out -1. So like this. You have to expand by using Fourier rule. So 1 minus u squared times 1 minus u squared, you can use Fourier rule. 1 minus 2 times u squared plus u to the 4 times u squared du. you have to distribute u squared to the first, second, third terms. Just u squared negative 2 times u to the 4 plus u to the 6 du. You can find antiderivative, the 1/3 u cubed, negative 2/5 u to the 5 plus 1/7 u to the 7 plus c. The last one, you have to change back. What's it like u? U is cosine function. The final answer is the 1/3 cosine cube x minus 2/5 cosine to the power 5x plus 1/7 cosine to the power 7x plus c. This is whole idea for solving this problem. Like this. The next one. How can you solve this problem? How can you solve this problem? This one is, you have to use, yes, trickster, because we have here the constant minus x square form. How can you change 9x squared? This is like better. Change like this one. 이내거 x squared over. So what's that? The 4 is 2 squared minus 9x squared is 3x squared to the power 3/2. This one, like this. So what's that? Here, you have to use trickster. What's it like a trickster? Here. Was it like 3x is like root of x. So 3x equals a is like 2. 2 times sine theta. 2 times sine theta. Divided by 3. Was it like x? X equals, so 2/3 sine theta. You can find dx. What's it like dx? Dx is 2/3 sine theta prime is 2/3 cosine theta d theta. So like so, right? So we have this trigonometric substitution. You have to substitute. 이내거 what's it like x? X is 2/3 sine theta. We have 2/3 sine theta square over. Bottom on, you plug 2 sine theta into 3x. So we have the 2 square is like 4 minus only 2 sine theta square to the power 3/2. What's like dx? Dx is 2/3 cosine theta d theta. So 2/3 cosine theta d theta equals. 이내거 simplify 4 of 9 sine square. So what's that? You have to simplify here. The 4 minus 2 sine theta square is exactly 4 minus 4 sine square. Factor of 4. Factor of 4. So exactly 4 times 1 minus sine squared is right. This is exactly same to, what's that? So like this. What is 1 minus sine squared? What is 1 minus sine squared? Do you know identity? 1 minus sine squared? You're right. The 4 times cosine square. You can change it. This is what? 4. What's it for? 2 square. So we have 2 square cosine square of theta to the power 3 over 2. So 2/3 cosine theta d theta. Change it like this. Simplify. You have to cross out 2. 2. So this is same to the integral. The just I think the erase here is better. Only take out 4 over 9. 인eg어 탑원 해줬니 sine square of theta over. This is like 2 cube. The 2 cube is 8. The cosine cube. So this is 2/3. Take out 2/3. Take out 2/3 times cosine theta d theta. And simplify. So take out 8. So what happens here? 4, 2, 8 crossed out. We have only 1 over 27. This is same to what? 1 over 27. integral cosine theta is crossed out. Change it to the sine square over cosine square. What is like sine square over cosine square? Sine over cosine is tangent. We can change it. Tangent the square of theta d theta, like this. So how can you calculate integral tangent square? I'm going to use one identity, 1 over 27. integral tangent square of theta is exactly same to secant square of theta minus 1 d theta. You can use it. Next, find antiderivative. 1 over 27. So what's that? What is integral secant square? What's integral secant square? What's integral secant square? No, not this one. The integral secant square is only tangent. The integral secant theta, integral secant theta is ln of secant plus tangent. Integral secant square is just tangent. Tangent theta. The integral one is just theta. So we have it. The next change back by using triangle. How can I make a triangle? We can use here. 3x equals 2 sine theta. You can change it. The divide by 2. 3x divided by 2 equals sine theta. You can draw triangle. The sine theta is 3x over 2. So how can you find this one? You can use Pythagorean theorem. This is 2 squared equals to 4 minus 3x squared is 9x squared. You can make a triangle. So what's that? This is same to 1 over 27. Tangent theta is exactly the 3x over square root of 4 minus 9x squared. 3x over the square root of the 4 minus 9x squared. Minus, what is like a theta? The theta is from here. You can use inverse function. You can change it. This one to the like inverse sine of 3x of 2 equal to theta. Can you replace here? Inverse sine of 3x over 2 plus c. So distribute 27 So final answer is the next one. The 3 is crossed out. We have x over 9, the square root of 4 minus 9x squared. The 1 over 27 times minus 1 is negative 1 over 27. Inverse sine of 3x over 2 plus c. That's it. This is final answer of this question by using trigonometric substitution. Like this. The next thing, integral 4x cubed negative 4x minus 3 over 2x squared minus x minus 1. So how can you solve this problem? So this is polynomial over polynomial form. You can use partial fraction, but not yet, because top one power is 3, bottom power is 2. Top one power is greater than or equal to bottom power. Long division is first. You have to reduce top one power. You have to long division. What is like long division? I can write here. The long division is, you can use it. 4x cubed. So we don't have x squared term. I can write the plus 0x squared negative 4x minus 3 divided by 2x squared minus x minus 1. You can use it. The next two, I can do that. You need 2x. The 2x times the 2x squared is 4x cubed. 2x times minus x is negative 2x squared. Minus 1 times 2x is negative 2x. The next, subtract. The 4x cubed is cancelled. The 0x squared is gone. Only negative 1 times minus 2x is positive 2x squared. The negative 4x minus negative 2x is negative 4x plus 2x, negative 2x. The negative 3 is like down. So we have negative 3, so like this. So we need only 1. The 2x squared times 1 is 2x squared. Minus x times 1 is negative x. Minus 1 times 1 is negative 1. You have to subtract. 2x squared is gone. The negative 2x minus here x minus x is negative x. So like this. Negative 3 minus 1 is the negative 3 plus 1, negative 2. So how can you write? This is the same to like this. Integral the quotient 2x plus 1, quotient form, plus remainder negative x minus 2. Negative x minus 2 over 2x squared minus x minus 1 dx, like this. This is not a final. So you need to find simple form. You can use partial fraction for minus x negative 2 over 2x squared minus x minus 1. Was it like a partial fraction? You just use this idea. Negative x minus 2 over, I know factor, 2x squared minus x minus 1. How can you factor? Like this one. 2x plus 1 times x minus 1. You can factor. So this is exactly 2x squared minus x minus 1. You can just change it to the a over the 2x plus 1 plus b over 2x, sorry, not 2x, x minus 1, right? x minus 1. So you can combine. How can you combine? Multiplication, cross multiplication. A times x minus 1, a times x minus 1 plus b times 2x plus 1, b times 2x plus 1 over the 2x plus 1 times x minus 1. So we have it. This is same to, what's that? Ax minus a plus 2bx plus b over the 2x plus 1 times x minus 1. The next, combine x terms. Ax plus 2bx is exactly a plus b. Sorry. This is same to here, a plus 2b. X, the remaining part is the negative a plus b, negative a plus b over the 2x plus 1 times x minus 1. You can compare this original one with your resulting form. So what's like a coefficient of x? Coefficient of x is a plus 2b, exactly same to minus 1. So we have one equation, a plus 2b equals minus 1. What's a constant? Minus a plus b. Minus a plus b is here, negative 2. So negative a plus b is negative 2. Next, solve this system of linear equations. Add a is gone, only 3b equals negative 3. Divided by 3, the b equals minus 1. You plug into first equation, second equation, it doesn't matter. You can plug like here, this equation. So what happens here, b into here. The 2 times minus 1 is negative 2 equals minus 1. Just add 2 to the both sides, a equals 1. So we have it. You can plug a is what? 1. P is minus 1. So we have this equation. A is what? 1 over 2x plus 1 plus P is minus 1 over x minus 1. So you can plug this partial fraction into here. So we have this result. 이내거 2x plus 1 plus 1 over 2x plus 1 minus 1 over x minus 1 dx. Like this. So you can calculate the distribute 이내거. The first one 이내거 2x dx plus 이내거 1 dx plus 이내거 1 over 2x plus 1 dx minus 이내거 1 over x minus 1 dx. So first one, very simple. 이내거 2x is x squared. 이내거 1 is just x. How can you calculate this one? I want to use this one. 이내거 g prime of x over g of x dx. What's that? ln of absolute value of g of x plus c. Here, you can like think about denominator 2x plus 1 is like g of x. Was it like 2x plus 1 prime? Was it g prime of x? Was it 2x plus 1 prime? Yeah, 2. So I can change it. This one is times 2 divided by 2. So like this one. You can keep 1 over 2. You can use formula ln of absolute value of 2x plus 1. Here, same. X minus 1 is g of x. G prime of x is just 1. We have negative ln of x minus 1, absolute value of x minus 1 plus c. So that's it. This is the idea. So one more, you can combine. 1 over 2 is going to power, same 2, ln of change square root, absolute value of 2x plus 1 minus ln absolute value of x minus 1 plus c. You combine the 2 ln x squared plus x plus ln the square root of absolute value of 2x plus 1 over absolute value of x minus 1 plus c. This is final answer for solving this problem. Like this. Okay, the next one. Yep, you're welcome. The next, we think about the improper integral of type 1. Was like improper integral of type 1? Case 1. Integral from a to infinity f of x dx is limit. Integral from a to t f of x dx take limit t value approach infinity. Second case, integral from minus infinity to b f of x dx is similar. Limit t value approaches minus infinity, integral from t to b f of x dx. The improper integral is conversion. What does it mean? The limit value exists. The improper integral is diversion. So if the limit does not exist. The third case, the improper integral is the minus infinity to infinity f of x dx. How can you solve? You can split two improper integrals, integral from minus infinity to a f of x dx plus integral a to infinity f of x dx. The integral minus infinity to infinity f of x dx is conversion. So what does it mean? Both improper integral are conversion. What's like diversion? The either one is diversion. This is like exact improper integral of type 1. The second type. Case 1, discontinuity at B. So how can you solve this one? You can replace this continuous point B by T and take limit. It's right here, so like this. So what does it mean? B. So we have discontinuous at B. You can choose a T value and find integral a to t f of x dx. Next, you have to take limit. T value approaches B from the left. B from the left. Second case, discontinuity at A, like opposite one, so similar. So only difference is here. It's like A and B, same. You can choose T between A and B, fine. This is like integral from T to B. Next, T value approaches A from the right, so like this. The improper integral is conversion if the limit exists. The improper integral is diversion if the limit does not exist. Third case, discontinuity at C. The C is between A and B. The integral from A to B, f of x dx, integral from A to C, f of x dx plus integral C to B, f of x dx. So integral A to B, f of x dx converges if both improper integrals are convergent. The improper integral is divergent. Either one is divergent. It's like exact definition. So we think about this problem. It's like type 1. So how can you solve? Here, you can change the limit. Integral from 0 to t, x times e to the minus x, t value approaches positive infinity. So how can you solve this problem? This is exactly algebraic function times exponential function. Exactly the product of algebraic function and transcendental function. We have to use integration by parts. We can use integration by parts. How can you use integration by parts? It's the same. We can use LIATE. Was like x is algebraic function. E to the minus x is exponential function. Was like u? The u equals the top on x. The dv equals like bottom on e to the minus x dx. Here, was like du? du is x prime dx, 1 times dx. Was v? The integral e to the minus x. Integral e to the minus x is negative e to the minus x. So this one is Kim limit. T value approaches positive infinity. So what's like the first one here? U times v. So we have x times negative x times e to the minus x from 0 to t minus integral 0 to t here. The v times du, the negative e to the minus x dx. So we have it. This is same to limit. T value approaches infinity. So first one, negative x e to the minus x from 0 to t. You can change this one to the positive one. The integral e to the minus x is like negative e to the minus x from 0 to t. You can calculate limit t value approaches positive infinity. You can plug t first, the negative t e to the negative t minus you plug 0, 0 times e to the 0 minus same plug t e to the negative t minus e to the 0. This one. This is the limit t value approaches infinity. This is 0. I can change it. This one to the negative t over e to the t. Distribute negative 1. This one is the negative the 1 over e to the t. So this is 1. This is 1. Minus 1 times minus 1 is positive 1. You can take a limit. T and e to the t. I'm going to use relative rate of growth. So e to the t is growing faster than t. So this is going to 0. So this is 1 over infinity is going to 0. What's the answer? This is 1. The final answer is the improper integral 0 to infinity. X over e to the x dx is conversion. The conversion to 1. This is whole idea for solving this problem. Like this. The last one. Integral 3 to 7, 1 over x minus 5 here. So what's that? The number 5 is between 3 and 7. You can plug 5 into bottom one. What happens? 1 over 5 minus 5 to the 4. 1 over 0, undefined. So what does it mean? The function 1 over x minus 5 to the power 4 is discontinuous. Discontinuous at 5. At 5. So how can you solve? You have to split two improper integral by using this continuous point 5. So I only solve this one, the first one. How can solve? You have to use U substitution. So U equals inner function x minus 5. So what's it like du? X minus 5 prime is 1 times dx. So next, the first, I can check. This first one is conversion or diversion. The first one is diversion. You don't calculate second one. Answer is diversion. The first one is conversion. You have to calculate second one. The second is conversion. Answer is conversion. Second is diversion. Answer is diversion. Depending on the first one. I want to check. The first one is conversion or diversion. This is like this continuous point 5. You can change it like this. The limit t value approaches 5 from the left. So integral from 3 to t 1 over x minus 5 to the 4 dx. Y here. We have 3 to 5. This is like this continuous point. You can choose t. You can find integral from 3 to t. The t value approaches 5 from the left. You can change it like this one. You can use U substitution. So this is same to what? Like this. You can plug U into here. We have U to the 4. So what's it like du? dx. dx is same to du. The next one, you plug 3 into here. G of 3, you plug t into here. We have G of t. So same to like this. You plug 3 into here. 3 minus 5 is minus 2. You plug t into here. The t minus 5. This is same to what? Integral. So limit t value approaches 5 from the left. So this is the same to integral negative 2. The t minus 5 u to the negative 4 is right. You can change it. This one to the u to the minus 4. You can use power rule. Limit t value approaches 5 from the left. 1 over negative 4 plus 1 to the u to the minus 4 plus 1 from negative 2 to the t minus 5. The next, the simplify. So what's that? This one is the 1 over negative 3. U to the negative 3. You can change it. This is negative 1 over 3 times u cubed. Right? So minus 1 over. So 3 times u cubed. So we have it. You plug the t minus 5 into u minus. You plug negative 2 into u again. So we have it. The next, so what happens? You plug 5 into here. What's that? Minus 1 over 0 form. So we have 2 possible answers from the one side limit, the infinity or negative infinity. How can you check? The minus 1 is like negative 1 more. The t value approaches 5 from the left here. This is minus 5. The t value approaches 5 from the left. I can choose test number 4.9. You plug 4.9 into here. The 4.9 minus 5 is minus 0.1. Minus 0.1 to cube is minus 1 cube is minus 0.1 cube is negative number. So bottom one is also negative. So what does it mean? Negative over negative is positive. So answer is positive infinity. So like this. What's that? The improper inequality is divergent. This is like the whole idea for solving this problem. Okay, this is like all for today's lecture. Maybe Kasha will cover the remaining parts tomorrow. Okay, thank you, all of you guys. Bye.